Okay, good morning. So you might wonder that I'm not around. Okay, I won't be there during the class, but I'm just doing a video record on our next topic. Okay, this must be on our finals. I'm not around today because I need to go, or I have an appointment in my embassy. So that's why I'm not around. On this video, we will just talk about the fractions. Okay, and by the way, for the attendance, maybe I'm going to give you a Google form so that you can fill up that form, and then if you fill up that form, meaning you are present during my class, okay, at least this time. Alright, so let's go back for the fraction. Fraction, first we have understanding rational numbers. Okay, a rational number is a number that can be written as a ratio in the form of m over n, okay, where m is an integer and n is a non-zero integer. So m is an integer, we'll just call it numerator. Then for the n here should be a non-zero integer. So we'll just call that denominator. Okay? As such, a fraction is considered a rational number when both numerator and denominator are integers. So again, both numerator and denominators are integers. Okay, let's get here. For example, 24 is a rational number as it can be written as 25 over 1. So if you remember, we have kind of a real number, okay, a number. Okay, from our additional math, we have this number 24, and then I just call it as 24 over 1. Okay, I just hope you remember that. Okay, when that was um, calculating fraction. Okay, we have included a real number or a whole number. So here it is. We have 24. We can write this one as 24 over 1. So next thing, we have 0.03. So 0.03 is a rational number also, as it can be written as 3 over 100. So what we do here, if we have a decimal point right here, okay, all we need to do, move this decimal point, count, okay, going to the right. So start from here, 1, 2. So if we have 1, 2, all we need to do, make this number 3 as a whole number, and then all over or divide it by 100. So we have 1 and then 2 zeros. So see again, we have 1, 2. 1, 2. So that's why we have wrote 100 as the denominator. Okay, that's how you should write a decimal number. Okay, it's also a rational number. We have to write it as make the number 3 as a whole number and then all over 100. Okay, another case also for this. Let's try 0. Okay, 0.2 zeros and then 3. So again, we have to count 1, 2, 3. So make the number 3 as a whole number, and then we're gonna need to add 0 in this part. So we have 3 over 1000. Okay, so on and so forth. We can also write another 0. So again, count 1, 2, 3, 4. So add 0 here. So this must be 1, 2, 3, 4 zeros. Alright, but this time this is 0.03. We'll just have to do it as 100. So we have 3 over 100. Okay, next up we have negative 1.8. Okay, negative 1.8. This can be written as negative 9 over 5. Okay, you might wonder how did I get negative 9 over 5 here. All I need to do, make this a whole number. Let's say, I'm gonna add it here. We have a negative 18, and then all over. Okay, I'm gonna need to use fraction. So, okay, a negative sign here. So again, we have to make this as a whole number. So from this decimal point, going to the right, so we count 1. So it's only 1. We have to do it as right as 18 over 10. Okay, next, from this on, we can simplify or reduce to the lowest term. So don't worry about reducing lowest term. I will just explain it later. Okay, from this part, we have to do that and then that. Let's just say dividing both sides with 2. So divide 2, we have, okay, I'm going to have to use another fraction. So divide 2, this is 9, okay? And then 10 divide 2 is equals to 5. So from this negative 9 over 5, we cannot simplify or we cannot reduce it to the lowest term any further. So that's why we have to stay right there. Right, so that's how you can convert a decimal point into a fraction. Okay, this decimal point also, decimals is also a rational number because it can be written as a ratio form or a fraction form. So we'll just close that. Alright, next we have, okay, we have 0.888, then we have dots here, we call this so on and so forth. 0.8888, so on and so forth. So meaning a never ending 8 here. So we have a decimal point and the number 8. Okay, and then these triple dots here meaning never ending 8. So I'm not gonna explain this how did I get 8 over 9. Anyway, you will understand this one further when you go M2, or that will be next year. Okay, we have this topic in M2. So you can write this one also into a rational form. Okay, next up we have square root of 4. So for this square root of 4, we can simplify this. Okay, it is equals to 2. Okay, then this number 2, it can be written as 2 over 1. So thus, square root of 4 is a rational number as well. Okay, but see, we have square root of 2. Square root of 2 is not a rational number, as it cannot be written as a simple fraction. Okay, this square root of 2 cannot be written as a simple fraction. Okay, this number is also known as a rational number. So if we have a square root of 2, this is known as a rational number. Okay, irrational numbers, rational numbers, and real numbers. Again, we have this topic on M2. I'm not explaining it today or right now, but when you go M2, you will learn about that. Okay, and here, another examples of irrational numbers. Here we have square root of 3, square root of 11, and we have pi. Okay, right, for square root of 2, so we say if we will find the square root of 2, that must be 1 point something. So 1 point something. I'm not sure. I gotta need to use calculator for this one, but all I can say, square root of 2 we cannot write it as a simple fraction, because for this number we have to do 1 point something, like 1 point blah blah blah, as well as square root of 3. So square root of 3 we cannot also find, or we cannot write it as a simple fraction. Okay, unless if we have, unless if we have a square root of, let's say, square root of 9. Yeah, square root of 9, we can have the answer of 3. Okay, so this 3 here, we can now write it as a rational number, or in a simple fraction. That will be 3 over 1. And also we have square root of 16. Square root of 16, we can have a 4 after we square root that 16. So again, we can now write this into a simple fraction. Okay, others, we have square root of 2, square root of 3, and square root of 11. We cannot write it as a simple fraction. Then we also have a pi here. Pi, we have value for that pi, that is 3.142, or we can have 22 over 7. Although we write it as 22 over 7, but it is not really the real exact value of the pi. Okay, we just call it, or we just write it as initial value for the pi. Okay, so I'll just take it right here. Hang on. That would be 22 over 7. So any measurement, if we includes a pi, okay, that will be an initial value for that we have is 22 over 7. But if you really want to try the value of pi, go on, search it wherever you want. Then it must give you a long list of a number. That will be 3.142.185. Oh, I just forget about it. Okay, I'm sorry, it's not 3.142. That will be 3.14158, and so on and so forth. Yeah, we just call it 3.142 because 5 can be round off to the whole number, so we just call it 3.142. Alright, so proceed. Write the following numbers in the form of, okay, we have this ratio or a fraction, m as the numerator, n as the denominator. First we have 0.4. Okay, solution, we have 0.4. That will be written, okay, as 4 over 10. So again, we have to move this decimal point on the right side. Then we'll count 1. Okay, so we have to write 4, and if only 1 places, so we have to write it as 10. 1 place, one place. Move the decimal point 1 place only, so write it as 10. Okay, so this is not the final answer yet, because 4 over 10 can be reduced to the lowest term. So reduced to lowest term, we have 4 over 10. Let's think. 4 and 10 can be divisible by a number 2. So meaning 4 divided by 2, then 10 divided by 2. So 4 divided by 2 is 2, and then 10 divided by 2 is equals to 5. Then look at 2 over 5. Is this the final answer? Can we reduce it to the lowest term? The answer is no. So meaning this 2 over 5 here is our final answer. I'm gonna write this one. Okay, this will be our final answer. Okay, next. we have negative 4.17. Okay, look at here, let's look for the solution. Negative 4.17. Again, we have the decimal point here. Move it to the right. We have to make it as a whole number and then count how many places we've been after the last number. So we have 1 and then 2. So 2. So this must be a negative 400. Sorry, I forgot to write negative right here. Okay, negative 417 over 100 because we move only 2 places. Okay, then what do you think for this? Can we reduce it to the lowest term? The answer is no. So we'll just take it as the final answer. Oh, yeah. And voila. Okay, next we have a mixed number. We call this mixed number. We have if we have a whole number together with the fraction. Okay, this is what we call mixed number. Solution. Okay, I'm just gonna give you the right answer. That will be 17 over 3. Why? So what we did here, we take this number 3, multiply it by the number 5 here, and then next plus or add it with our numerator 2. That's why we have 17. So again, 3 times 5 is 15. 15 plus 2 is 17. And then 3 here shall remain the same. So here, 3 times 5, and then add 2. So that is our 17. So that 17, we have to write it as a numerator. Okay, write it as a numerator. And then next, number 3, it shall remain as denominator. So that's why we just write it right here. So here now, we'll just call this an improper fraction because as you see, we have the numerator is larger than the denominator. So that's why we call it an improper fraction. So this is a proper fraction, which is 2 over 3. Then notice 2 is much more smaller than our denominator. We'll just call it as a proper fraction. Okay, but if we will see that the numerator is larger or higher than our denominator, we just call it as an improper fraction. Okay, right? This one here, we call this as mixed number. Okay, proceed. This is for properties of rational numbers. Okay, I forgot to mention you this part here, chapter 2. Okay, if you have your textbook there, please open it to page 30. Chapter 2, rational numbers, page 30. Okay, properties of rational number. So property 1, so we have the property 1, I call this as when finding LCD. Don't worry about this, I'll just explain it to you how you find the LCD, or shall we say the least common denominator. Okay, he says the value of a rational number remains unchanged when its numerator and denominator are multiplied by the same non-zero integer. So multiplied by not zero integer. So have this. Okay, this is the proper fraction, and then we have multiply it with the same number. Okay, this is not a zero or non-zero integer. For example, we have 1 over 2 or 1/2. Okay, then what if we will find a least common denominator? We just need to multiply it by 5. only if needed. So we have 1 times 5 equals to 5 over 2 times 5 is equal to 10. Okay. But then 5 over 10 here, we can just simplify to the lowest term. It shall return us into 1 half. See, the value remains unchanged even if we multiply it by the same number. Okay, I call this as when finding LCD, because for example we have to find the LCD of two fractions. Say two fractions here, we have 2 over 3 and 3 over 4. Okay, find the LCD or the least common denominator. So we need to find, okay, both of these fractions here, we need to find their common denominator. Okay, so that we can calculate these two fractions. Okay, find the LCD of 3 and 4. The answer is 12. Okay, so here we have to multiply the denominator with number 4 just to get 12. Okay, then if we multiply this denominator with a number, then we have to multiply it also with the same number. Okay, because we are looking for the denominator or the least common denominator. Alright, so finally calculate. We have 8 over 12. 8 over 12. Okay, that is for the 2 over 3. Okay, and for the next one we have 3/4. 3 over 4. We have to multiply it with 3. So if we multiply the denominator with 3 just to get 12, okay, so that we can get the least common denominator, okay, then for the numerator also we need to multiply it with the same number, which is number 3. Right, so finally we have 9 over 12. Okay, then whatever operation they have for 8 and 12, or right here, whatever operation they have here, let's say we just take this one out. Let's say we have plus, okay, then we cannot calculate directly if both of the denominator is not the same. It's not yet the same. So we need to find first the LCD. Okay, so that is 12, the least common denominator. Then after that we can now add these two numbers. Okay, so again now we have this kind of problem in our additional math, which is the fractional indices. Alright, I will just go back to the end. Okay, so next property, property 2, I call this as when reducing to the lowest term. If you have a number or a fraction, if we need to reduce it to lowest term, this is the right possible solution. Okay, it says the value of a rational number remains unchanged when its numerator and denominator are divided by the same non-zero integer. Again, if the numerator and denominator are divided by the not zero integer, then the value of it remains unchanged. Alright, we have this kind of formula. So for example, we have 100 over 40. Okay, that is for the example in our book, and you can find it in your book. So we can simplify or reduce it to the lowest term. We can have divided by the same number. So 100 divided by 4, 40 divided by 4. So 100 by 4 is 25. 40 divided by 4 is equals to 10. Okay, this is the example on your textbook. Although this part we can still reduce to lowest term. So we can have dividing both sides with a 5. So 25 divided by 5, and then 10 divided by 5. Yeah, this I will not elaborate it more because this is an example you can find on your textbook. We'll just have another one. Okay, let's say reduce the lowest term of this fraction. See, this time we need to divide both sides because we are about to find the lowest term. So think for a number, we have to divide it both sides, numerator and denominator, so that we can reduce it to the lowest term. That number will be 8. Okay, I know you, some of you there thinking 16 divided by 4. Yes, but after that we can still reduce it to the lowest term. We have to find a possible or a really larger number so that we cannot reduce it to the lowest term. So that number is 8. So we have 16 divided by 8 and then 24 divided by 8. Now we have 2 over 3. Now this 2 over 3 is our final answer because we cannot reduce it further. So 2 over 3 is our final answer. Right, next, we have the property number 3. I call it as a cross multiply. So for this cross multiply here, you can or we can use this kind of solution during M3. I have a subject or a topic for this one that we really need to use a cross multiply. So don't worry, you will use that during your M3. Okay, when you go 2 years after. Alright, so for example, we have 1 over 7 equals 12 over 84. Okay, so what happened here? We have number 1, multiply it with 84. So let me so multiply to 84. Okay, and then for number 7 here, multiply it with 12. Okay, then if we multiply 1 to 84 equals, do not forget the equal sign. Equal sign, and then we have 7 times 12. Okay, so calculate 1 times 84 is 84, 7 times 12 is also 84. So therefore this is correct. So don't worry about this cross multiply. We can use this one during M3. Okay, so see you there. Alright, next property we have property number 4. So I can't give a name for this one, but really it's just stating whether the statement is correct. Okay. Right here we have if A, B, and C are rational numbers and A is greater than B and B also is greater than C, then A must be greater than C. So this is just a statement. So we're just stating if the statement is correct. So for example, we have if 0.5 is greater than 1/3 and 1/3 is greater than 0.2, then 0.5 must be greater than 0.2. So this is correct because for 1 over 3, if we just calculate this one, we have 1 over 3, we can just say as 1 divided by 3. So 1 divided by 3 cannot be, so we need to add a decimal point and then add 0 after 1. So now we have 10. Okay, we'll just conclude it as 10. So we have now 10 divided by 3. Okay, 10 divided by 3. Then we have the final answer for that we can get is 0.3. So we have 0.5 is greater than 0.3, Okay, and then must be, or shall I say, maybe closer than 0.3. Okay, and then 0.3 is greater than 0.2. So it states the statement is correct. Okay, next we have test yourself. Alright, this one you need to prove the followings are rational numbers. You may find this question on your textbook, page 31. Okay, we have 0.216. Again, like what we did here, on the top. I don't want to scroll it up. I'll just stay right here. Okay, all we need to do, take this decimal point, okay, because we need, or it must be, take as a whole number. So this decimal point, we have to move it to the right, then count how many places we have after to the last number. So we have 1, 2, 3, that will be 3. So we shall write it as 216 over, then if we have 3 times moving the decimal point, so we have to write as a 1000. 1, 2, 3, 3, 0. So 216 over 1000. Now question, can we reduce it to the lowest term? The answer is no. So we'll just remain it as that for the final answer. Okay, next up we have negative 4.21. So negative 4.21, again we have decimal point, count or move to the right side and then count how many places we had after the last number. We have 1, 2, so we need to do it as negative 421 divided by, or over 100. Okay, and then we cannot reduce it to the lowest term, so remain it as the final answer. Alright, next we have 2. So 2 here, we all know this number 2 has a denominator of 1, so we just write it as 2 over 1. Final answer. Next, we have a negative number, negative 41. So again, if it's a positive or negative, that number must have a denominator of 1. So this will be negative 41 over 1. Okay, for number 2, verify if these are correct. And then we just have a variable a here, which is equals to 12. We have the variable b is equals to 6, and then c is equals to 2, and then d is equals to 1. Okay, what we need to do here, we have this kind of question. We just need to replace the value of each of the variable here with the number, because each of them has a value. First question, we have a over b is equals to a times c over b times c. So a, replace the value, we have 12 over, where's that? Okay, right here. Okay, 12 over a is 12, our b is 6. Okay, then we have 12a times c. Our value of c is 2. So multiplied by 2, and then b also multiplied by 2. So we have 12 times 2, and then 6 times 2, that is 24 over 12. Okay, now it says both have the same value. Thus, this fraction here is correct. Okay, because if we do, we can simplify or reduce the lowest term or reduce it. We can still, or it will return as this fraction here. So that means that's correct. Okay, next we have A over B. Now this time we do simplifying or reducing to the lowest term. So 12 over 6 again, and multiply it with a C, which is a value of 2. So 12 divided by 2 and 6 divided by 2. 6 over 3. Okay, again, so if we multiply it with 2, it will return it as the same fraction here. So both have the same value, thus this fraction is correct. Alright, next. Uh, if A over B is equals to C over D, then A times D is equals to B times C. So this is the cross multiply. The cross multiply. Okay. We have A is 12, B is 6, C is 2, D is 1. So then 12 times 1 equals 6 times 2. So 12 times 1 is 12, 6 times 2 is equals to 12. So meaning both have the same value, thus it is correct. So remember the question now, we just need to verify that these variables and the numbers here are correct. So meaning this part, it is correct. Okay, lastly we have if A is greater than B and then B is greater than C, then A is greater than C. So replacing the values of A, B, and C, now we have A is 12, B is 6. Okay, 12 is greater than 6, it's correct. B is 6, C is 2. Now 6 is greater than 2, correct. Then A must be greater than C. So our A is 12, then our C is 2. Then it is indeed correct. So the statement is correct. Okay, that's the end of the rational number. Okay, I'm gonna need you to do a few of it. Just need you to answer your textbook. No, answer your workbook page. Hang on. Okay, page 18. Okay, only one page. And I need you to answer 1, 2. 1 and 2 only. Okay, for number 1, I need to answer A, B, C, okay, D, D, okay, skip letter E, skip that letter E, proceed to letter F, skip letter G, proceed to letter H. Okay, for number 2, all you need to do, you have to write 5 examples of irrational numbers. Okay, that would be A up to E. A to E. Okay, please remind your other classmates also if they are not here or if they were absent. Please remind them to answer the workbook as well. It's only one page. Then I just need you to skip few of those questions on number 1, that is E and G, because that question might be hard for you to answer. Okay, that will be on your M2 next year. Alright, so I hope you understand all of this, and don't worry, maybe I'm gonna send all of this after 30 minutes before this video will end. Okay, so that's it all for today. I hope you learned something and have a nice day. Goodbye. Goodbye and goodbye. Keep safe.